In the previous videos, we decided to modernize OMS to cloud native. We also saw that the technical debt was quite low, leading to a low modernization effort as well, with a score of 1 out of 5. In this video, we will demonstrate how to decouple OMS into 3 Spring Boot microservices. Let's first move on to the discovery phase. From the dashboard, we will initiate a real-time discovery of OMS. To do this, we switch to the application-specific view and select the associated controller. This controller acts as an interface between the deployed application and the vFunction solution. Once the controller is selected, we will launch active discovery to determine the domains, functions, and resources used by the application. From there, we will move on to the REST API query generation workshop. To achieve a complete discovery, it is necessary to cover the maximum number of use cases. OMS being a headless application, meaning it is accessible via REST APIs, we will generate sufficient traffic for an initial discovery. The goal is to create as many interactions as possible for a comprehensive discovery. Therefore, a prerequisite is to have sufficiently rich test cases. This testing workshop executes a series of queries for the creation of various objects, such as those for inventory, products, and purchase orders. Some queries are solely for consultation, knowing that some of them are complex and query multiple objects at the same time. Complete coverage is beyond the scope of this video, but we will continue assuming that it has been done. We load the results of a complete discovery into vFunction. We see that 9 domains have been discovered, along with 92 functions and 79 resources. The domains in green are already very decoupled, while those in blue will require a bit more work. We switch to the analysis screen. On the right, we see the details of the 9 domains with the main Spring MVC controllers, which correspond to the business objects of OMS. On the right, we find each domain along with the number of associated dynamic classes. For example, in the case of the inventory controller, we see in detail that there are 3 entry points, 4 dynamic classes, 6 static classes, and 7 resources. If we zoom in on the 3 entry points of the inventory section, the work of transforming the application code begins. This is carried out by the software architect of the application, assisted by the vFunction workshop. Without going into the details of the vFunction modernization workshop, the goal is to create the 8 domains and ensure that they are exclusive to one another. This outcome allows for the creation of the 8 microservices that will replace the monolith. In the case of inventory, we now have 4 entry points via REST APIs. Once this decoupling is completed, we will extract the 3 services that interest us. We select the inventory, product, and purchase order services. These will be the only 3 microservices we create in this video. Then we switch to the service creation view, which will allow us to extract the cutting patterns from the original source code. During this extraction, we select the target platform, Spring Boot, the Java version, and the type of assembly tool to be used. Once the configuration is done, we download the patterns and just need to follow the instructions for disassembling the source code. Now let's move on to the development activities. Once the code is extracted, the development teams take over to make the final modifications to the source code. In the software workshop displayed on the screen, we see the 4 new source code directories. 3 pertain to our new microservices, while the 4th groups the new common libraries. Looking more closely at the right side of Visual Studio, we see the files that need to be modified for the new product inventory service. These modifications concern 3 main categories. First, the application runtime elements. Second, those related to the intrinsic structure. And finally, the classes enabling access via API. In total, this represents between 10 and 20% of the code. This highlights the benefits of such tools, which drastically improve modernization times. All that remains is to reassemble the microservices and deploy them on the new hosting target. The final phase involves deploying the 3 microservices in a Kubernetes environment. We do not cover the integration and continuous delivery phases, but instead use the built images directly for deployment. The Kubernetes interface clearly shows the 3 built microservices. Each one is autonomous and offers its own REST API services. The database is the same as that of the original OMS application, allowing interaction with the same data. Each container contains a Spring Boot instance. Unlike Medrec and Cloud Ready, the cloud native modernization is therefore much more advanced. Thanks to the decoupling into three microservices, each can have its own lifecycle. For example, the evolution velocity for the purchase order management service may be greater than that of the inventory service. This decoupling provides that flexibility. Additionally, using a Kubernetes foundation will allow for shorter delivery cycles and more agile deployment strategies. The inventory service is now available via a REST API. A global or unit search can be performed. This is done on a headless service, allowing for the creation of a new user interface, for example in low code, while overcoming the debt. The modernization is far from finished, but this is already an important first step towards its implementation.